Uh-oh. Suppose I should go let that person in. All right, Alex, get here on time. Vlad, come on in. All right, so example 3 here, similar to the previous 2 examples, is not your normal, quadratic equation. We cannot, in other words, use the fundamental theorem of algebra to determine how many solutions this guy has right off the bat, right? Because this is not a polynomial equation. Remember, a polynomial equation is an equation where there's, like x to the second, x to the third, x to the fourth. In other words, the square root here is messing us up. Okay? So what have we done before regarding square root equations? Have we talked before about it? Absolutely. Jack, what do I do when I'm trying to solve a quadratic, or excuse me, solve a radical equation like this? Yeah, we try to get the square root by itself. So one technique for this problem is to kind of go that route, where we isolate the radical, we raise both sides to that power, and then we simplify and solve, okay? So let's do that over here on the left in blue. So the first thing I'll do is just add 3 square root of x to both sides. So I got 3 square root of x, and then x plus 2, all right? So when I square both sides, Lewis, what process do I need to use on that right-hand side? Very good. We're going to FOIL that right-hand side out. At this point in the year, fellas, I'm leaning on you a little bit to have the ability to FOIL a binomial, square binomial in your head, okay? So Charlie, what's that right-hand side going to give us? Very good. X squared plus 4x plus 4. Now, the left-hand side is not a binomial. It's a monomial that happens to have 2 factors. So when I square the left-hand side, I want to square the first factor as well as the second factor. So what's that, Jack Candiato, what's that going to give me when I square the left-hand side? Very good. It's going to give me 9x. Now, class, we have going through 2 steps in the process. Now we have turned that original equation into a, what kind of equation now? This equation is somebody said it, it's a quadratic equation now. So from this point down, how many answers am I going to get? I'm going to get 2 answers. However, we have to be on the lookout for what? Somebody said it louder, please. Yeah, the extraneous solutions. Sometimes we encounter those. Do we remember what an extraneous solution is? It would be an answer that it results from this equation, but that when I plug it back into the original black equation, maybe it doesn't work out. Okay, so just being on the lookout for that. So 0 equals x squared. What am I going to do? Subtract 9x. So minus 5x plus 4. So that's going to be x minus 4 and x minus 1. This one factors out. That's easy enough. Did not have to use my quadratic formula. And so here we got x equals 4 or x equals 1. And I need to quickly check to see if either of those is extraneous. I'll leave that to you guys. I will leave that to you guys. Nate, what do you think? Have you checked either answer? Oh, you've just been sitting there. Tisk, tisk. Reed, have you checked either answer? 4 works. Great. Glad to hear that, James. 1 also works. So we got 2 answers to this equation. So the second approach that we could take here, and we'll do it in red, we found both of our legit answers. We can go ahead and box that up now and say, here are my solutions. The second approach that we could take to this problem is to turn it into a quadratic equation of sorts. All right. The hard part about that is realizing to let you, or whatever letter you're going to stand, let you represent the thing that sort of has been repeated in it. So like in example 2, we let u equal that quantity right there, that u minus 2. In example 1, we said, okay, x squared, and then x squared squared, so we said x squared showed up a couple times. In other words, it shows up in that middle term, right? So what do you think? What the heck happened to my let u equal? Where'd that go? Did you guys see what happened to that? Oh well. Let u equal. What shows up in that middle term that you think I might have a good idea of substituting in there? Paul? Very good. Let u equal the square root of x. Now I can rewrite this problem as u squared minus 3u plus 2 equals 0. Okay, you say, well, wait a minute, where'd you get u squared? What's the square root of x times the square root of x? What's the square root of x squared? It's x. That's what that first term is, right? And so, again, we see that this is quadratic in nature. Now, does this one factor out? Factor it for me. U minus 2, u minus 1, and therefore u equals 2 or u equals 1. Now, why would I not finish right there and say, we're done? Quentin, I like how you raised your hand, Quentin. Go ahead. Exactly. It's nice to know that u equals 2, but what does u stand for? So the square root of x equals 2, or the square root of x equals 1. Okay, and then how do I get x by itself on both of those? Square both sides. So we got x equals 4 or x equals 1, and we see both of those solutions as being legitimate because we've already tested them out. Okay. Now you might say, Coach Warren, I appreciate the blue one better. I'm quicker. I'm better at the blue one. Okay. Or you might say, okay, the red one makes more sense to me, and that's fine. Be versatile. Be able to work it both ways. But I'll go ahead and tell you that the more elegant approach over here in red will have a wider variety of applications. That means that it will work with more problems, okay? The way that we did it here in blue is also going to be a little bit more time consuming in some problems, okay? So our substitution principle is what we want to roll through with. Questions on example 3? Go for it, Jack. I missed the very first thing that you said. You said, wouldn't something also work? Okay, that's that's like saying 6 in one hand, half a dozen in the other. So like, check this out right here in green. Like if we squared both sides, you're absolutely right. The right-hand side would be x, and the left-hand side would be u squared. So yeah. That's just looking at the red technique from a different point of view. Go for it, Lewis.
In the blue, why is the 3 radical x not negative? Because
it was negative to start with, and I added it to both sides. I felt like, you know what, by adding it to both sides, I can get it by itself in one step, and I can also keep things positive, right? Good question there, because the x and the 2 were already positive, so I said, y'all boys, y'all stay over here. I'm going to move this negative 3x over to the other side and change sides. Good questions. Let's look at another one. Ooh, this one looks challenging. Can you think of something to let u stand for? I'll take anybody's ideas. Think of something to let u stand for. James? Fabulous. That's exactly what I would do. Let u equal x to the 1/3. Let u equal x to the 1/3. Okay? So what does that first term become then? It's u squared. Because think about it like this. X to the 2/3 is the same thing as x to the 1/3, what? Squared. Because when we raise something to a power and then to another power, it's where we're supposed to multiply the exponents, okay? And so if u is x to the 1/3, then u squared would be x to the 2/3. What would u cubed be? I'm just curious. What would u to the 3rd power be? Yeah, just x to the 1st. Right? In other words, if you declared your variable, you can answer any question you want to about it. Just by, all right, like if I said, oh, what is u cubed? If I cube this side and cube that side, oh, u cubed would equal x. Okay, and we can kind of play around with it as needed there. All right, but the idea here is that I want to change this in terms of, instead of in terms of x, I want to write it up in terms of u. So this first term is u squared, second term is 2u, third term is 24. Does that factor? What are your two factors? So that means u equals 6 or u equals -4. What is u the same thing as? X to the 1/3. So how do I get x by itself? Good. Cube everything. So 6 cubed is 216. And -4 cubed is -64. Now, what do I want to double check? Look for the extraneous solution, right? So this one's going to be a little bit challenging, but we can still plug and chug in our heads here. 216, okay. I definitely don't want to square 216 and then take the cubed root. I want to take the cubed root first and then square it, okay? What I mean by that is, again, right up there, you can take the cubed root, in other words, raise it to the 1/3 power first, and then square. So when we plug in our first answer of 216, what is the cubed root of 216? We just said it is 6. What's 6 squared? So that first term is 36, all right? Minus 2 times, all right, what's the cubed root of 216? 6. And we want to see, does that equal 0? All right, well, 36 minus 12 is 24, minus 24 is 0. So 216 checks out. And then -64, I don't want to square -64. I want to take the cubed root of -64. What's the cubed root of -64? What kind of 4? -4 squared is 16. All right, so minus 2. We just said the cubed root of -64 is -4, and then minus 24, and we want to say, does that equal 0? All right, well, let's see here. -2 times -4 is +8, so that's 16 and 8 makes 24. 24 minus 24 equals 0 indeed, so both of those answers check out. No extraneous solutions there. Okay, that one's a little bit tougher because it's got the fractional powers, the fractional exponents. So take your time and remember, class, what's the phrase that pays when it comes to fractional exponents? Do you remember how we talked about the phrase that pays? 3 little words, Luke. That a boy. Power over root. Write that down if you haven't seen that in a while. Power over root allows me to look at something like x to the 1/3 and say, oh, x to the 1/3 is just the cubed root of x. And sometimes we're more comfortable dealing with something in terms of a radical than we are in terms of an exponent. Because again, remember here, I'll zoom in. Power over root means that that power is 1 and that root is 3. So x to the 1st power under the cubed root. Okay. Question, Grove.
How did you go from x to the power of 130 equals 6 to x equals 216?
Somebody said it over in this back region. You said cube everything, and that's exactly what we did. So we raised both sides to the 3rd power. Because raising some 1/3 to the 3rd, again, we multiply these exponents, and 1/3 times 3 is 1. In other words, those guys cancel out. It just gives you x to the 1st power. And the 6 cubed is 216, having memorized that. Similarly, we cubed everything on this side too. Those canceled. And -4 times -4 times -4 is -64. All right, y'all want to try one more? You can do it. I'm going to let y'all try this one on your own. We had fractional exponents in the last example. Now we got some negative exponents. Dun, dun, dun. Use substitution, though. What shows up more than once, use substitution. Solve it out and look for the extraneous solutions at the end. Tiago, what'd you let U stand for? Very good. That's our first step, fellas. Let U equal x to the negative first, because we realized that x to the negative second would therefore be what? U squared, right? So if U equals x to the negative first, then U squared equals x to the negative second, and we could just do a straight substitution. Alex, rewrite it in terms of U now.
3u squared minus 7u plus 2 is 0.
Fabulous. George, what factoring technique should you use? All right, good. So back to work. If you've already finished, kudos, double check your answers. If you're still grinding away, maybe that gave you a little bit of a leg up if you were stuck. Quadratic equation in black is going to have two solutions, and that doesn't necessarily mean that those both will be legitimate solutions, but we can test and verify. Paul, what two answers for U did you get? U equals this or U equals that? No, I don't think so. Somebody else get something different, Joey? U equals 2 or U equals 1/3. Does anybody concur with that? All right. The reason, Paul, that I shot you down without thinking about it too much is that when we factor out using the magic method, I know that we're going to have at least one answer is going to have to be a fraction. Otherwise, it would have worked out differently. Now, if U equals 2 or U equals 1/3, that means that x to the negative first equals 2, or x to the negative first equals 1/3. Now, what in tarnation do I do after that? Quentin? All right, so let's change one word. You said multiply everything by the -1. I think you mean exponentiate, or raise everything to the power of. Raise both sides to the power of -1. You know, like in the last problem, we said, hey, just cube both sides. Or in the problem before, we might have said, oh, raise both sides to the second power. Here, we're going to raise both sides to the negative first power, okay? And when I do that, you're absolutely right that -1 times -1 simplifies out to a +1. So I got x equals 2 to the negative first. Jake, what is 2 to the negative first? 1/2. Very good. So x equals 1/2. And then over here, again, similarly, those two exponents are going to cancel each other out. So we got x equals 1/3. And Drew, what is 1/3 to the negative first power? Not 1/6. Will Edwards, do you know? Already heard from James. What about Joe? It is 3. Very good. Whoops. Now, some of y'all might be wondering, what the dump is he even talking about? He might as well be speaking Greek up there. All these negative exponents and all this flim flam. So like, let's take a different tact here in blue. I'm gonna rewrite what we had. Whoops. Supposed to be blue. There we go. All right, so x to the negative first equals 2. And instead of doing what Quentin suggested, which by the way was totally legit and totally fine, and I like it, why don't I just handle x to the negative first? Like, Nate, tell me, what is x to the negative first the same thing as? Just out of this context, just in and of itself. Out of this, like ignore the entire problem, and if I just, like a month ago, if I said, hey, Nate, what's x to the negative first power the same thing as? You would say it's 1 over x. Okay, because when we have a negative exponent, that's where we say, you change its position in the fraction. If it's not a fraction, you can always divide by 1. And anything that has a negative exponent, we move. If it's up top, we move it down to the bottom. If it's at the bottom, we move it up to the top. That's how we deal with negative exponents. All right. So x to the negative first power, class, is again what? 1 over x. Good. So we got 1 over x equals 2. All right. Now at this point, you might say, well, coach, just multiply both sides by x. And then you could say, well, coach, divide both sides by 2. And you got your answer of x equals 1 over 2. It's just in black, it's a little bit less work. Raising both sides to that same power gets the job done. Similarly, okay, similarly over here, we had x to the negative first equals 1/3. Okay, class, again, what's x to the negative first? The same thing as 1 over x equals 1 over 3. Can you make the connection there? Right, you see how both of them are on the bottom and the numerators are the same? If not, how do you solve well, first of all, what kind of equation is this where you have a fraction equaling a fraction? Starts with a P, ends with row portion. It's a proportion. Alex Cano, how do I solve a proportion? Fruit Ninja champion that you are. Well, I thought you might have been a Fruit Ninja champion. Maybe I was wrong. Paul? Cross multiply. All right, we multiply 1 times 3. We multiply x times 1. And we get x equals 3 again. Okay. You'll see how we're reviewing some stuff that we've already talked about this year. Negative exponents, power over root, solving proportions, solving quadratics. In these equations, I'm not doing anything new. I am making use of some old strategies that we've already learned in a new context, okay? So I've taught you no new math in these 5 examples. We've just been using the math that we've already learned in a different context, in a new way, which is really what learning's all about, okay? You learn how to do something, and then you think, oh man, where could I use this newfound skill of mine? And you put it into action, all right? So you're teaching your brain to think a very unique way. That's one of the things that I like about algebra. All right, questions? Quentin. Well, we didn't check them, did we? 1/2 and 3 are our 2 answers. Let's check them real quick. 3 times 1/2 to the negative second minus 7 times 1/2 to the negative first plus 2, and we want to see, does that equal 0? Now let's see here. See if you guys can help me. I'll zoom into the red one. What's 1/2 to the negative second power? Negative exponent, when we raise a fraction to a negative exponent, that's the same thing as doing with the fraction. Flipping it. And so if I raise it to the negative second, I'm going to flip it and square. 1/2 flipped is 2, squared is 4. 4 times 3 is 12. First term becomes 12. Did you see how quickly we did that in our heads? Okay. What about 1/2 to the negative first? What is that? That's 2. 2 times 7 is 14. Does that check out? It certainly does. Okay. What was our other answer? Just 3? All right. 3 to the negative second would be, flip it, you get 1/3 squared, which is 1/3 times 1/3. 1/9. Thank you. 1/9 times 3 is. Good morning, Coach Gray.
One quick question.
Yes, sir.
If you're taking the 4th root of a perfect square, can you take the square root of the square root?
Yes, you may.
Just the 4th roots? Like 5th root, I could take the square root of the cube.
You can split your root up into a product and do either factor first. So like if you had the 10th root of something, you could take square root and then the 5th root, or the 5th root and then the square root.
Okay. And as multiplication?
Uh-huh. No, well, not necessarily multiplication.
Square root of the square root for the 4th root. I'm just doing 4th roots.
Yeah, that's the same thing as the
perfect square. I can take the square root of the square root.
That's the same thing as the 4th root of x. Yes, sir.
Sorry about it.
No worries. What were we just saying? You'll help me with my first term. 3 to the negative second we said was 1/9. 1/9 times 3 is 1/3. 3 to the negative first in the middle. 1/3 times 7. 7/3. All right, what's 1/3 minus 7/3? Negative 6/3 is the same thing as negative 2. Negative 2 plus 2 equals 0. Checks out. Both of those answers are legit. And so we finish our lesson. And you guys go out and have a wonderful day. I've got the feeling that you are not practicing at home like I've asked you to. What makes me get this feeling? When I look on Delta Math and I see 0%, 0%, 0%. Y'all need to be daggone working. Log on to Delta Math. Do your practice, okay? I know it don't count for anything, but it helps you. Some of you guys are doing a good job of that, so keep it up. All right, live Jesus in our hearts. All right, fellas. Thanks. Have a wonderful day.